Pre-statistics. Solving linear inequalities in one variable. Part 4. Lesson objective. Use linear inequalities to make estimates and predictions about real-world problems. Lesson objective. Example 10. The perimeter of a square must be less than 160 feet. What is the maximum length of a side in feet? B. Mercury has the lowest melting point, negative 37.8 degrees Celsius, of all metals. Write an inequality for the melting point of any other metal. C. A long board must be split into 4 sections so that each section is at least 3.5 feet long. What is the minimum length the board can be? Solution. A. Let's let S be equal to the length of the side of the square. A square has 4 equal sides, and the perimeter is the length of all the sides added up. So the perimeter is 4S. We want the perimeter to be less than 160, so we have the following inequality. To solve for S, we divide by 4, and S is less than 40. So to answer the problem, we say each side must be less than 40 feet. B. Let M be equal to the temperature of the melting point. Then the inequality M is greater than negative 37.8 degrees is the inequality. C. Since the board must be split into 4 sections, we are going to divide by 4. So let X be equal to the length of the board. We have X divided by 4. At least means greater than or equal to. So we have a greater than or equal to 3.5. Solving for X, we need to get rid of the 4. So we do the opposite, multiply both sides of the inequality by 4. And we have X is greater than or equal to 14. So to answer the question, the minimum length of the board is 14 feet. Example 11. A carnival has 2 plans for tickets. Plan A is $8 entrance fee and $1.75 for each ride. Plan B is $5 entrance fee and $2.25 for each ride. After how many rides would you have to take for Plan A to be less expensive than Plan B? So our first step is to write an expression for Plan A. We let T be the number of tickets. So for Plan A, that becomes 8 plus 1.75 times the number of tickets, T. For Plan B, 5 plus 2.25 times T, the number of tickets. So the question asks, how many rides would you have to take for Plan A to be less expensive than Plan B? Less expensive means less than, so we want to know when is Plan A less than Plan B. Substituting our expressions in for Plan A and Plan B, we have the following inequality. 8 plus 1.75 T is less than 5 plus 2.25 T. Solving this inequality, we're going to subtract 2.25 T to both sides. That leaves us with 8 minus 0.5 T, which is less than 5. Subtract 8 to both sides. We have negative 0.5 T is less than negative 3. Dividing by a negative 0.5, and don't forget to flip the inequality sign, we have T is greater than 6. So when the number of tickets is more than 6, Plan A is less expensive than Plan B. We can verify this by using the graphing calculator. So we take the left-hand side of the inequality, put that in y1. We take the right-hand side of the inequality, put that in y2. Then we use our table feature, which is second graph, and we want to know when is y1 smaller than y2. When x, the number of tickets, is 6, y1 and y2 are equal. And when it goes larger than 6, y1 is smaller than y2. Example 12. The revenues of Guitar Center stores are shown in Table 58 for various years. Let f of t be the revenue in billions of dollars in the year that is t years since 2000. Predict the years when the revenue will be more than 2.2 billion. Now, more than means greater than. That's an inequality. So we're going to take this data, construct a linear model, and then use that linear model to predict when that model will be more than 2.2. So our first step, our new independent variable is t, the number of years since 2000. The revenue would be r, so we need to put t in list 1 and r in list 2 in our graphing calculator. So once we have the data in list 1 and list 2, we want to look at the pattern of the data. So we want to construct a scatter plot. So you hit second y equals, make sure it's turned on, make sure it's a scatter plot. X list should be list 1, the y list should be list 2. Now we hit the zoom and number 9 for zoom stat, and here's our scatter plot. This does look like roughly a linear pattern. To find the model that fits this linear pattern, we hit the stat button. We use the right arrow key to calculate, then number 4, which is linear regression. We hit enter. This pastes the linear regression command in the home screen. Hit enter again, and then we have our line of best fit. A is the slope, B is the y-intercept. To check to see how well this model fits the data, we hit our y equals, and round it to 2 decimal places, we type in our line of best fit, which is 0.10 x plus 0.84. Hit graph, and we see that this line fits the data pretty good. So we're going to use this model for our prediction. The function becomes f of t equals 0.10 t plus 0.84. Since we are interested in predicting when will the revenue be larger than 2.2, we have the following inequality. 0.10 t plus 0.84 is greater than 2.2. Subtracting 0.84 to both sides yields 0.10 t is greater than 1.36. Dividing by 0.10, we have t is greater than 13.6. So in the terms of the problem, we would say, according to the model, the revenue will be more than 2.2 billion in about the year 2014. And that's when t is greater than 13.6 years. We can verify this by using the graphing calculator. If we hit second graph, which is table, scroll down to where x is 14, we see that is the first year when the revenue is larger than 2.2. Thanks for watching.